Hi everyone, welcome to Aviksha Avi YouTube channel. In this video, I start with some of the important rules and previous year exam problems under divisibility rule. For my previous videos, please go through my links which is provided in description box. Okay, the divisibility rule under this, some of the important divisibility rules are: rule number 1. A to the power of n minus b to the power of n is divisible by a minus b and a plus b if n is an even number. This I will explain with the help of an example. Eight to the power of 6 minus 3 to the power of 6 is divisible by dash. Suppose if they ask a question like this, firstly we have to compare this given data with the rule. Here if you observe, the given data is 8 to the power of 6 minus 3 to the power of 6. This is of the form 8 to the power of n minus b to the power of n, where n is an even. Here 6 is an even number. So according to this rule, we can written 8 to the power of 6 minus 3 to the power of 6 is divisible by 8 minus 3 and 8 plus 3. Here a is equal to 8 and b is equal to 3. I just compare this with this rule. Okay, now 8 minus 3 is 5 and 8 plus 3 is 11. Now 8 to the power of 6 minus 3 to the power of 6 is divisible by 5 and 11. This all about this rule number 1. Says that 8 to the power of n minus b to the power of n is always divisible by a minus b if n is an odd number. This also I will explain with the help of an example. Suppose (11 to the power of 7 minus 3 to the power of 7 is divisible by . Here if you observe, the given data is of the form 8 to the power of n minus b to the power of n, where n is odd. So if I just apply this rule, when I apply this rule, 11 to the power of 7 minus 3 to the power of 7 is divisible by a minus b, that is 11 minus 3, which is equal to 11 minus 3 is equal to 8. So 11 to the power of 7 minus 3 to the power of 7 is divisible by 8. This is all about the rule number 2. Next, rule number 3. Rule number 3, a to the power of n plus b to the power of n is divisible by a plus b if n is odd number. For example, 12 to the power of 7 plus 5 to the power of 7 is always divisible by To find out this is of the form a to the power of n plus b to the power of n, where n is odd, that is 7 is a odd number, so n is odd. So I apply the rule, that is 12 to the power of 7 plus 5 to the power of 7 is always divisible by a plus b. A plus b means 12 plus 5. 12 plus 5 which is equal to 17. So 12 to the power of 7 plus 5 to the power of 7 is always divisible by 17. Next, rule number 4. a to the power of n plus b to the power of n. If n is even, then it cannot be determined. It means it cannot be solved. This all about the rules, some of the rules in the divisibility. Now based on this rule, we will solve some previous year Ctet examination questions. Number 1, 2 to the power of 10 minus 1 is divisible by. They are given options as 2, 3, 4 and 10. This question is asked in TET November 2012. Here the given data is 2 to the power of 10 minus 1. Suppose if I raise any power to 1, it becomes 1 itself. So for my convenient, I just raise the power 10, that is 2 to the power of 10, write as it is, minus 1 to the power of 10. If I raise 1 to the power of 10, it becomes 1 only. So I raise 1 to the power of 10 for my convenient. Now this is of the form a to the power of n minus b to the power of n, where n is an even, because this 10 is an even number. So this is given data is approximately is equal to this rule. So from this rule we can write 2 minus 1 into 2 plus 1. Here I just compare a with 2 and b with 1 by applying this rule. Now 2 minus 1 is 3, 2 minus 1 is 1, 2 plus 1 is 3. Now if you look at the options, they given only 3. So 3 is the correct answer. Here we just apply the rule. The question number 2 is 23 to the power of 10 minus 1024 is not divisible by, and they given an options 5, 3, 4, 7. Here if you look at the given data, that is, first I will return the given data. Here they given 23 to the power of 10 minus 1024. This is the given data. Here if you look at this given data, one number is in the form of a to the power of n and another number is in the form of number itself. So now I just convert this number in the form of a to the power of n. So we can return it as 23 to the power of 10 minus 2 to the power of 10. We can write this. I will show. I just 1024 is divisible by 2. 2 5s are 10, 2 1s are 2 2s are, then 2 2s are 2 5s are and 2 6s are, 2 1s are 2 2s are 2 8s are, 2 64s are 128, 2 32s are, 2 16s are, then 2 8s are, 2 4s are, 2 2s are, then 2 1s are. When we count this 2, 1 2 3 4 5 6 7 8 9 10, so we can return 1024 is equal to 2 to the power of 10. I just apply this here, that is 1024 is equal to 2 to the power of 10. Here if you look at the power, both powers are even. So I apply rule number 1. What this rule number 1 says means a to the power of n minus b to the power of n is divisible by a plus b, a minus b if n is even. If n is even, I just apply this rule here. That is, here I compare a with 23 and b with 2. So I just compare and I return 23 plus 2 and 23 minus 2. When I add up, 23 plus 2 is 25. Here 21. Now we have to search the factors for this 25 and 21. The factors for 25 are 1 and 5, because 1 into 25, 25, 5 5 is a 25. So 1 and 5 are the factors for 25. Now we have to search the factors for 21. The factors for 21 is 1, 3, 7. These three are the factors for 21. Now if you observe this, 23 to the power of 10 minus 1024 is divisible by this 25 and 21 according to this rule. Similarly, this 23 to the power of 10 minus 1024 is divisible by 1537, because these 1, 5, 3, 7 are the factors of 25 and 21. So we can write this 23 to the power of 10 minus 1024 is divisible by 1, 5, 3, 7. Now look at the question. They ask that not divisible by. So here 5, 3, 7 are divisible. That is 5, 3, 7 are divisible. But here they ask for not divisible. Here the remaining term is 4. So 4 is the correct answer for this question. So 4 is not divisible. Question number 3. If n is a whole number greater than 1, then n square into n square minus 1 is always divisible by. The options are given like this: 16, 12, 10, 8. Here the given data is n is a whole number greater than 1. Here whole number means 0, 1, 2, 3, so on. But they given that n is greater than 1. So we have to consider n is equal to greater than 1 means 2, 3, 4, like that, so on. Now put n is equal to 2 in given data, that is n square into n square minus 1, which is equal to 2 to the power of 2, 2 to the power of 2 minus 1, 4 into 4 minus 1, 4 3 is 12. Now the value of n square into n square minus 1 is 12, that is n square into n square minus 1 is equal to 12. The value of this is 12. But in the question they asked that n square minus 1 is divisible by. N square into n square minus 1 is divisible by. It means 12 is divisible by. Here if you observe the options, 12 is not divisible by 16. So option A is not correct. Then 12 is not divisible by 16, so it is not correct option. Next, option number B. 12 is divisible by 12, so option B is correct. Option C, it is also not divisible by 10, so it is also not correct. Then option D, it is also not exactly divisible, so it is also not correct answer. So here it satisfies option B. Now suppose if you put n is equal to 3. Here I just consider n is equal to 2 for this case. Now I just take n is equal to 3. Suppose I consider n is equal to 3. I will replace the value n square into n square minus 1, which is equal to 3 square minus 1 9 into 8, which is equal to 72. In this square, n square into n square minus 1 is equal to 72. Here the value of n square into n square minus 1 is equal to 72 when we put n is equal to 3. Now they ask that n square into n square minus 1 is always divisible by. It means 72 is always divisible by. For this I will go through for the options, that is option number A. 72 is divisible by 16? No, it is not exactly divisible, so it is not correct option. Then option B. 72 is divisible by 12. Yes, it is divisible. 12 6 is 72. So it satisfies. 12 only here satisfy. Then we go for option 3. 72 is divisible by 10? No, it is not divisible. Now option D. 72 is divisible by 8. Yes, 8 9s are 72. So it is also divisible. Now we have a confusion whether we have to consider option B or option D. For this, please go through for the option B, because in two cases, that is when n is equal to 2 and when n is equal to 3, in two cases it satisfies 12 only. So we have to go through the majority. So here the correct answer is 12. Here it satisfies 8 also, but in majority cases it satisfies 12. So we consider 12 is the correct option. Question number 4. If n is even, then 6 to the power of n minus 1 is divisible by the given options like this: 37, 35, 30 and 6. Here they given that n is even, so just put n is equal to even values, that is 2, 4, 6, 8, etc. When we consider n is equal to 2, this given data becomes, that is 6 to the power of n minus 1 will become 6 to the power of 2 minus 1, that is 35. 36 minus 1, which is equal to 35. This 35 is exactly divisible by 35 itself from the option B. So option B is a correct answer. Suppose if you consider n is equal to 4. Here also 6 to the power of 4 minus 1, which is equal to 1296 minus 1, which is equal to 1295. This 1295 is also exactly divisible by 35 only. It is divisible by 35. So here in this case also 35 is the correct answer. So 35 is the correct answer. Now before going to next question, we have small note. Please note down it. Note number 1. If A is divisible by B, then AC is also divisible by B. This I will explain with the help of an example. Suppose put A is equal to 4 and B is equal to 2. Now just apply this note, that is A is divisible by B, that is 4 is divisible by 2. Suppose if I multiply 4 with 5, that is, which is equal to 4 into 5 by 2. I just multiply 4 with 5. Now it becomes 20 by 2. Then also this product is divisible by 2, that is 2 ones are 2 tens are. So we can say that if A is divisible by B, then AC also divisible by B. Next, note number 2. Note 2. If A is divisible by B and B is divisible by C, then A is also divisible by C. That is, if A is divisible by B and B is divisible by C, which implies A also divisible by C. This is note number 2 says. Next, note number 3. If N divides D and M divides D, then M plus N and M minus N divides D. This I will explain with example. Suppose put N is equal to 48 and M is equal to 16. This I just consider to show this rule, and take D is equal to 8. Why I taken D is equal to 8? Because this 8 divides both 48 and 16. This all are I consider according to this note only. So that is N divides D and M divides D. Here N means 48. 48 divides 8 and 16 also divides 8. Now M plus N. M plus N means 48 plus 16, which is equal to 64. This 64 also divisible by 8. 64 is divisible by 8. Now M minus N. M minus N means 48 minus 16, which is equal to 32. This 32 is also divisible by 8. So we can say M plus N and M minus N is divisible by D. This all about the note. Now based on this note we will solve some problems. Question number 5. 4 to the power of 61 plus 4 to the power of 62 plus 4 to the power of 63 plus 4 to the power of 64 is divisible by dash. They given the options like this: 3, 10, 11 and 13. Now I just write down the given data as it is. That is, here the given data is 4 to the power of 61 plus 4 to the power of 62 plus 4 to the power of 63 plus 4 to the power of 64. Now write 4 to the power of 61 as it is. Now I just take common factors in all remaining 3 factors. For this I just split this 62 as 4 to the power of 61 into 4 to the power of 1. This I written according to the rule, that is a to the power of m into a to the power of n, which is equal to a to the power of m plus n. Here 4 to the power of 61 into 4 to the power of 1, which is equal to 4 to the power of 62. Here I just apply this rule. Similarly, we have to apply this rule for this 4 to the power of 63. 4 to the power of 63 3 can be written as 4 to the power of 61 into 4 to the power of 2 plus 4 to the power of 61 into 4 to the power of 3. I just split according to this rule. Now I will take the common factor among this all, that is 4 to the power of 61 is the common factor if you observe. Now remaining is, if you take common factor 4 to the power of 61, here the remaining factor is 1 plus 4 to the power of 1 plus 4 to the power of 2 plus 4 to the power of 3 is the remaining factor. Now I just simplify it. 1 plus 4 plus 4 4 16 plus 64. When I add up this all, 4 to the power of 61 into 85. Now I just divide this 85 by the given options, so that if 85 is divisible by given option, then the whole term is also divisible by divisible. Here I just apply the note 1, but here 85 is not divisible by any of these options, so we go for further simplification, that is 4 to the power of 60 into 4. We just apply this rule here into 85. Then 4 to the power of 60 write as it is, when 85 into 4 is 340. Here this 340 is completely divisible by 10. It is completely divisible. So this entire term is also completely divisible by 10, because I just apply note number 1, that is A divides B, which is equal to AC also divides B. I simply apply this rule here, that is 340 is divisible by 10. So 4 to the power of 60 into 340 is also divisible by 10. So here it is divisible by 10. By 10. So here the correct option is 10. Next question is question number 6. 3 to the power of 25 plus 3 to the power of 26 plus 3 to the power of 27 plus 3 to the power of 28 is divisible by. This question is also similar to above one. Now I just write down the given data, that is 3 to the power of 25 plus 3 to the power of 26 plus 3 to the power of 27 plus 3 to the power of 28. Now I just split this. I written 3 to the power of 25 as it is plus 3 into 25 into 3 to the power of 1. 3 to the power of 25 into 3 to the power of 2 plus 3 to the power of 25 into 3 to the power of 3. Here also I just apply a to the power of m into a to the power of n, which is equal to a to the power of m plus n. Now when I take the common factor outside, 3 to the power of 25, the remaining is 1 plus 3 to the power of 1 plus 3 to the power of 2 plus 3 to the power of 3. 3 to the power of 25, which is equal to 1 plus 3 plus 9 plus 27. When I simplify it, 40. Now this 40 is not divisible from any options. So I go for further simplification, that is 3 to the power of 24 into 3 into 40, which is equal to 3 to the power of 24 into 120. Now this 120 is divisible by 30. It is completely divisible. So it is completely divisible. So according to note number 1, if A divides B, then AC is also divisible by B. I just apply this rule here. Here 120 is completely divisible by 30. So 3 to the power of 24 into 120 is also completely divisible by 30. So it is divisible by 30. Here the correct answer is 30. Next question is, the symbol triangle A drawn to any size means A plus 4, and this symbol rectangle B drawn to any size means B square, where A and B are numbers. Then the value of this equation is, they given the options, and this question is asked in the year 2012 in Ctet examination. Now before we going to solve this, we have to analyze the question. Solution. The symbol triangle A drawn to any size means A plus 4. It means triangle A, which is equal to A plus 4, and the symbol rectangle B drawn to any size means B square. It means rectangle B is equal to B square. Now we have to find the value of this equation where A and B are represents the number. Firstly, we have to write this equation as it is. That is rectangle inside plus 2 we have to find out the value of this equation. To solve this, firstly we have to solve from inside. So for this I consider triangle 3, which is equal to 3 plus 4, which is equal to 7. Here I just apply this rule, that is A, which is equal to A plus 4. I just apply this rule here. Here A is equal to 3. Now I solve this triangle shape. Its value is 7. Now I will solve for this rectangle shape, that is rectangle 7. I just replace the value of triangle 3 is equal to 7. That's all. Now I just apply the rule, this one. Rectangle B is equal to B square, that is 7 square, which is equal to 49. Now the overall value of this is 49 plus. Now we go for this second term, that is triangle 2. This triangle 2 is of the form, this one, triangle A, which is equal to 2 plus 4, which is equal to 6. Now the value of this triangle 2 is 6. Okay, now write as it is minus. Now next the remaining term is this, that is triangle into 4. Okay, here we have to solve from inside. So I consider this rectangle 4, which is equal to, I just apply the rule, that is 4 square, which is equal to 16. Now I got the value of this rectangle 4 as 16. So 16 write as it is. Now I apply the rule, this triangle A, that is 16 plus 4, which is equal to 20. Now the total value of this term is 20. When I solve this, I get the value 35. So here the correct answer is 35. We just replace the values, that's all. Next question is question number 8. The product of two whole number is 24 and the smallest possible sum of these numbers is, the given options like this: 8, 9, 10, 12. And this question is asked in the year 2014 February Ctet. Here they given the product of two numbers, that is 24. So I can written A into B is equal to 24, where A and B are the whole numbers. Here I just written the given statement in the form of mathematical form. Now I search the factors for this 24. I search the factors for this 24. For this, that is 1 into 24, which is equal to 24. And they ask for the smallest possible sum of these numbers. So I just add up these factors, that is 1 plus 24, which is equal to 25. Similarly, I search one more factor for the 24, that is 2 into 24, 2 into 12. 2 12s 24. Here also I just add up these factors, 2 plus 12, which is equal to 14. One more factor for 24 is 3 8s 24. Here also I just add up 3 plus 8, which is equal to 11. Next, one more factor is 4 into 6, which is equal to 24. 4 plus 6 equal to 10. Now, these all are the factors for the 24. Now, if I look at the smallest possible sum, then we get 10 is the smallest possible sum. So, 10 is the correct answer. Suppose if they ask for the highest possible sum of the factors, means we have to choose 25. But here they ask for the smallest possible sum. So I choose, this is the smallest possible among these all factors. So I choose this option. Next question is question number 9. The product of integers between -7 and -3 is, the given options like this: 120, -120, 840 and -360. This question is also asked in the year 2015 and Ctet examination. For this, firstly we have to draw a number line. I just written here the number line, and here I place the 0 and 1 2 3 in this side, left side -1, -2, -3 I just written here. Now in this question they ask for the product of integers between -7 and -3. That is, they ask the product of integers between -7 and -3. The products between -7 and -3, the integers which are present are these: -6, -5 and -4. Now we just multiply. Product means we have to multiply, that is -6 into -5 into -4. Here first I just multiply the number, that is 6 5s are 30, 34s are 120. 120 is the 120. Now we have to multiply for sign. Minus into minus, plus, plus into minus, minus. So -120 is the correct answer. If you have confusion regarding this sign, just refer this table, that is minus into minus, plus, plus into minus, minus. So finally we get the negative answer, that is 120 minus 120. Here next question is question number 10. The additive inverse of S, where S is equal to 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 plus so on to plus 49 minus 50 is, they given the options like this: 0, 25, minus 25 and 1. And this question is asked in the year 2015 September in the Ctet examination. Now, before going to solve this question, we have to know the meaning of additive inverse. Additive inverse means, here the word additive inverse means we have to consider reverse or opposite sign. Additive inverse means we have to consider the reverse or opposite sign. Now they given S is equal to this, and we have to find out the additive inverse for this S. For this, I just consider the given data as it is here. Now I just make two terms as one group, that is, I just make the two terms as one group, like this. I just make two terms as one group. Okay. Now, if I solve these two terms, that is 1 minus 2. 1 minus 2 is minus 1. 3 minus 4. 3 minus 4 is minus 1. 5 minus 6, that is minus 1. 7 minus 8, that is minus 1. Here also minus 1. Now, for two terms, if you observe, for the two terms we get minus 1. That is, for two terms we get minus 1. Okay. For four terms, that is 1, 2, 3, 4. For four terms, we get minus 1 into minus 1, which is equal to minus 2. Here minus into minus plus, so 1 plus 1, 2. So I just add up the number as a 2. Now I put the sign of the bigger number itself, but here the both numbers are same, so I just consider the minus. Now for 6 terms, minus 1, here I already find for 4 terms, so I just directly consider minus 2 into minus 1, which is equal to minus into minus plus, so I just add up 2 plus 1 is 3. Now the sign of the bigger number I just take, that is minus 3. Now for 8 terms. 8 terms means minus 3 minus 1, which is equal to minus 4. Similarly, if you continue for 25 terms, we get, for 25 terms, similarly we have to consider up to 50 terms, because they given up to 50 terms also. For 50th term, we get minus 25 we will get. But I already said that the additive inverse means we have to consider the opposite sign. But here already negative sign came. So I want to consider plus 25, that is additive inverse of S is 25. Here the correct option is option number B. This problem we can also solve by another method. I will show. Here I just consider the given data, that is S is equal to this equation. Now I separate odd terms one side and even terms one side, that is 1 plus 3 plus 5 plus 7 plus 9 plus so on 49. and -2, -4, -6, -8, so on, -50. I just separate odd terms one side and even terms one side. Now I write as it is this one, odd terms 1 plus 3 plus 5 plus so on plus 49, and I take the common factor minus outside, so 2 plus 4 plus 6 plus 8 plus so on plus 50 we will get. Now this set of numbers are in AP. AP means arithmetic progression. Arithmetic progression means difference between any two consecutive terms are always constant. Suppose if you observe 1 minus 3, 1 minus 3 is 2, 5 minus 3 is 2. Similarly, if you observe here 4 minus 2 is 2, 8 minus 6 is 2. So these two sets of numbers are in arithmetic progression. Now we have to apply arithmetic progression formula for this sequence of numbers. That is, we have the general formula for the arithmetic progression, that is Sn is equal to n by 2 into 2a plus n minus 1 into d, where a is first term, d is difference, n is number of terms. This is the general formula for the arithmetic progression. Here for this sequence a is equal to 1 because the first term is 1, and d is equal to 3 minus 1 which is equal to 2, and n is equal to 25. Here why I taken 25, because they given the numbers from 1 to 50, that is they given numbers from 1 to 50. In this 1 to 50, 25 are odd numbers and remaining 25 are even numbers. Here 1 plus 5 plus 3, these are all odd numbers, so I just consider n is equal to 25. Similarly, I take for this sequence, I consider a is equal to 2 and d is equal to 4 minus 2 which is equal to 2 and n is equal to 25. Here this data is belongs to this one, and this data below data is belongs to this series. Now I just apply these values in the formula, that is n by 2 into 2a plus n minus 1 into d minus n by 2 2a plus n minus 1 into d. I just written the formula. Now I will substitute. Here n means 25 for this series, first series, by 2 into 2 1 plus 25 minus 1 into 2, 25 by 2 2 plus, I just substitute the values. Now I will simplify it. 25 by 2, 2 ones are 2, plus here 25 minus 1 means 24. 24 into 2 is 48 plus 48 minus 25 by 2 I written as it is, and 2 2s are 4 plus 48. Here I will get 625. Here I will get 650, which is equal to minus 25. But I already said that the additive inverse means we have to consider the opposite sign. So here we will get minus. So we have to consider plus 25, which is equal to plus 25, because additive inverse. So I consider plus 25 is the correct option. Question number 11. If AB into BA is equal to BCB, where A, B and C stand for just one digit, and A is not equal to B and B is not equal to C, then the value of A plus B plus C is, and they given the options like this: 6, 10, 9 and 8. This question is asked in the year 2016 Ctet February. To solve this question, I just consider AB into BA, which is equal to BCB. I just consider the given equation. I just consider the given equation as it is. Now just consider the values randomly as your wish. Suppose if you put A is equal to 1 and B is equal to 2. These values I selected randomly. Suppose if I put A is equal to 1 and B is equal to 2 in this equation, I will get 1, 2 into 2, 1. 12 into 24 is 252. 252. Here it satisfies the condition this. Here if you observe, I put A is equal to 1 and B is equal to 2. And I will get the same answer, that is B is equal to 2 and C is unknown, so that is 5 and B is equal to 2. So it satisfies the condition. Here C is equal to 5. Suppose if you consider another values like A is equal to 2 and B is equal to 1. Now you have to put these values in this equation, above equation, that is AB into BA, which is equal to BCB. Now I just substitute these values in this equation, that is 2, 1 into 1, 2, which is equal to 252. But here I taken B is equal to 1, but here in the LHS I will get B is equal to 2. So this condition is not satisfied with these values. So these values are not correct. Suppose if I consider one more values, put A is equal to 1 and B is equal to 3. Then AB into BA, which is equal to BCB. Now I just substitute 1 into 3 into 3 into 1. I will get 403. Here also I just taken the value B is equal to 3. But in LHS I will get the value B is equal to 3 and also B is equal to 4. So this also not satisfied the condition. So this is also wrong. So here the condition satisfied with the values A is equal to 1 and B is equal to 2. So for this they ask for to find out the value of A plus B plus C. So I just add up A plus B plus C, which is equal to, from this, 1 plus 2 plus 5, which is equal to 8. So here the correct answer is option D. Next question number 12. Shown here are expression given to Seema, Anis, Asha and Tezi with their answers like this, and who is the correct answer? This question is asked in the year 2012 January in the exam Ctet examination. In this question we have to check whether LHS is equal to RHS or not. For this, first we have to check for Seema. What Seema's equation is? Option A, Seema, its equation is 4 into 1 plus 8 divided by 2, which is equal to 8. Before going to check this equation, we have one rule, that is BODMAS, which means bracket of divisibility, multiplication, addition, subtraction. It means first we have to solve division, then we go for multiplication, then we go for addition, then finally we go for subtraction. Now I apply this rule for this equation. Here we have to check whether this LHS is equal to RHS. So I just consider LHS. So LHS equal to, this is the LHS. Here I want to first solve the division, that is 8 divided by 2. 2 ones are 2 fours are. So 4 into 1 right as it is plus 4. Next we go for multiplication. Here multiplication is 4 into 1 4 plus 4. Then we go for addition. 4 plus 4 is 8. Here subtraction is not present. So here the answer is 8, which is equal to RHS. So Seema did the correct answer. So first option. For your understanding, I will just one more. I will solve the Honey's answer, that is LHS is equal to 6 plus 4 divided by 2 minus 1. Here also I just apply this BODMAS equation, that is a bracket of divisibility. First I will solve the division. So I just write 6 as it is plus 4 divided by 2 means 2 ones are 2 twos are, so 2. Then minus 1 write as it is. Next go for multiplication. Here there is no multiplication, so just leave it. Then go for addition. Addition means 6 plus 2, which is 8. Minus 1 write as it is. Then go for subtraction. Subtraction means 8 minus 1, which is equal to 7. But in LHS, Anis is equal to 4, so it is not correct. Not equal to RHS, so it is wrong answer. Now I will go for Asha. Here the LHS is 9 plus 3 into 2 minus 4 divided by 2. Here I just first divide the division, that is 2 ones are 2 twos are. 9 plus 3 into 2 minus 2 I write as it is. Then we will go for multiplication, that is 9 as it is. 3 twos are 6 minus 2. Then we go for addition. 9 plus 6 is 13 minus 2, which is equal to 13 minus 2 is 11. But the answer is 10. So it is not equal to RHS. So this is also wrong option. So here Seema did the correct answer. So Seema is the correct. Here if you want, you can check this Tezi also. It is also not correct. Question number 13. Which of the following is correct? First option number first. Sum of two prime numbers is always a prime number. Option B. Composite number can be odd. Option C. There is no even prime number. Option D, 1 is the smallest prime number. And this question is asked in the year 2015 Ctet examination. Here I already explained the definition of the prime number in my previous videos. If you want, please go through it. The link is provided in my description box. Now this prime number means which cannot be divided by any number except 1 and itself. Prime number means the number which cannot be divided by any number except 1 and itself. Now I will give some more examples for the prime number. Examples are 2, 3, 5, 7, 11, 13, 17, like this, etc. These are the examples for the prime number. Now here in the option they given that sum of two prime numbers is always a prime number. Now I will check this option. For this I take sum of two prime numbers, means I just take this 3 and 5. That is 3 plus 5, which is equal to 8. 8 is not a prime number. Similarly, I consider 5 and 7. 5 plus 7, which is equal to 12. This is also not a prime number. So option number A, also option A, sum of two prime numbers is always a prime number. This statement is wrong. I here proved here. So option A is not correct. It is wrong. Now option B. Option B, what option B says means composite number can be odd. Here composite number means all non-prime numbers are called composite number. Example, I will give some examples for the composite number. That is 4, 6, 8, 9, 10, 12, 14, 15. These are the example for the composite number. Means composite number means the number which is not a prime number, that number is considered as composite number. Now here in the option they given that composite number can be odd. Now I will check that. Composite number can be odd. Here if you observe this 4, 6, 8, 12, 14 and also 10 are even numbers, and here this 9 and 15. 9 and 15 are odd composite number. So composite number can be odd. So option B is a correct answer. Now if you go for option C, that is there is no even prime number. This is a wrong statement because 2 is a even prime number. So this is a wrong statement. Next final one is 4. 1 is the smallest prime number. I already said that in my previous video. 1 is not a prime number nor a composite number. So this option is also wrong. So here the correct answer is composite number can be odd. So this is all about the divisibility rule and its problems. If you like my videos, please subscribe and like and click on the bell icon. Thank you.